Hey, good morning. I don't
Good.
know what it is there. Good morning here.
I think we're all on the West Coast.
All right, then good morning.
Oh, except, well, Austin's in Mountain Time, but yeah, good morning. Okay. So today we're just going to review what was done in the last I just use the term semester in the last semester, which was a lot of the research on the praise data. So we're going to sort of pick up where that left off as just a bit of a refresher. So labs, open up the agenda. Friday, October 8th. Okay. Cool. So reviewing praise research. Okay. So I had put a cleaned up collection of the praise research in the repository that was actually the voting repository when people were voting on praise interventions. So let me try to remember what that repository was called. Maybe intervention. Impact hour intervention. Yep. So if you look at the closed issues on this repository, this is a pretty cool piece of history because this was a repository that was connected to Gitcoin. Oh, wait, no, not Gitcoin. What's the system, the voting system on GitHub repositories? Tokenlog. So if we go Tokenlog. So for anyone in the call that isn't familiar with this system, it's actually really cool. It's a really fundamental component that comes in handy. Tokenlog is a token system that integrates with GitHub, so that if you have a token like an ERC20 token, for example, CStack is the ERC20 token, then you connect this. See, this URL here is going to be the exact same. It's going to match a GitHub repository. So we have commons build / impact hour interventions. So you connect this token voting system with a GitHub repository, and it just pulls all the open issues. So if we look at the open issues here, there's 4. Calculate the deductions off the cleaned raw data, and that shows up here, and then you can go and vote on it if you have tokens. Now I think if I'm on my laptop, which doesn't have, I don't think I have any impact hour tokens on here. In fact, I don't. So, but if I did, I could go and vote here.
That's so cool.
I know. Yeah, token-driven development. And you can run a whole organization like this. So if you go commons build, because issues don't just have to be software related. There's a repository on commons build called coordination, and this is just for the entire organization. See, there's 795 closed issues. So Gitbook, rules for praise and quantification, new feature video for YouTube, praise version 1.0 user stories, choice of back-end architecture, choice of front-end architecture, praise wireframes, forums update the Telegram pinned message. So these are just like directives for the entire organization. There's 205 open, and this is how the whole organization moves forward. So you could come in here and you go commons build / coordination, and you can actually vote on what you want the organization to be doing. I don't know if this will load because I think there's a bit of back-end setup that needs to be done, or maybe it's just slow because there's so many issues. But yeah, this is a pretty powerful combination of tools, GitHub and Tokenlog. So what happened with the impact hour intervention is right before the initialization of the hatch, there was the whole impact hour data set, and then everyone kind of said, hold the brakes here for a moment. Like, this praise data set is quite skewed. You know, there was one person who had about 7% of all the token allocation, and there was some people saying, well, it's a bit of a skewed distribution. So maybe we need an intervention or like apply a base rate UBI kind of thing. So it was this whole research project that we went into. So let me see if I can jump back to impact hour intervention. So if you look at all the closed issues here, oh, and let me link this first of all. Let me just go here. I'll put this in the agenda. And I'll also just drop it in the labs channel. Okay, now I'm going to clone this because I did have sort of the latest praise cleaning that I had done was in here, and I think it's kind of the latest. I took a lot of the work that Octopus had done and took sort of the best of it and compiled it all together. But it's been a few months since I've looked at this, so let's see what we got. Jump to TEC. Git clone. Open up Jupyter Lab. Okay, so this is the latest that we have, I believe. So let's see what we have. We have data. So we have the impact hour distribution analysis. This is a, now these are directly downloaded from Google Sheets. If we look at praise data, there's probably a Google Sheet praise quantification. So I don't know if this is, are they still doing this since the hatch? Let's see, the last one looks like it was July. I don't think there's been praise quantifications unless they're using a different system now. But I wonder where the data has continued because there's still praise happening. Anyways, let me link this. So this is the data source, praise, TEC praise quantification. Okay, so that's what we have here, basically a downloaded version of that sheet. Actually, that's what this would be. TEC praise quantification. So if we look at this is a very standard data science terminology, which is usually the first step in the pipeline, which is the extract, transform, and load. So that means we're going to extract wherever our data is coming from originally. We're going to transform it into a sort of nice workable format that we're able to work with. And then we're going to load it. That usually means like load it into a database or just drop it on disk as like a nice clean data set. So probably I have outputs. So I have all sorts of like intermediary data outputs. So this notebook probably drops something in here. So let's just run through this. So in this notebook, we extract data from the praise worksheet, transform it into suitable clean data, and load it into the outputs directory. So we get this TEC praise quantification. We grab a sheet called total impact hours so far, and we basically clean it up a little bit. We take the handle and the impact hours, and we also then put it into the outputs directory. So it's called totalhours.csv. So that's here. So we're going to create that from the original data set and drop it on disk. Looks like it takes a little bit of time. Okay, and it looks like this. So we already have, if anyone wants to be working with this data set, they can clone this repository and take a look at the outputs directory, and these are all of the sort of cleaned or processed data sets. So we have total hours for everyone. Let's see if we can just open that up here. So this is kind of fun to look through. There's WGG and Zeptimus, of course, and then we can separate. This gets separated out to receivers. So this is like a standard. This is a very standard praise data set. So we have praise going to, praise coming from, the reason for dishing. So this is the text message that the person puts in the praise when they post it. Praise for hosting this kicking params party. It's labeled with an institution, which is the channel, the praise channel that it's been posted in. So there's the Token Engineering Commons, and there's also praise. I think this is probably a Telegram. And then there's also some coming from the Common Stack. I believe that's the Common Stack Telegram as well. We have the date that praise was done. We have the room that it was praised in. So in Discord, you can actually praise in any channel. We have I think the weight of that praise. We have the translation into impact hours. So that's like the quantification. This is the total impact hours given to that person on that praise quantification session. So that represents about a month or 2 weeks. So in this case, we see that Zeptimus got a total of 39 impact hours in this May. This is the period of May, period number 17. And then batch. I'm not sure what batch is, but so basically this ETL pipeline, we're loading up all the data sets, we're cleaning them. We can just scroll through this and see some of the intermediary outputs. Looks like we do a group by period and we count. So we see all the periods here, January, December, October, May, April, March, February, January 29th, and how many praises were on each batch. So we had 963. So the most praises were in April, mid-April. We take a couple different batches. Oh yeah, this is because the people shifted the way that they were recording the data at different periods of time. So we have to, the way we isolate and clean the data out of there depends on which period it's coming from. So we treat each of those batches independently, and then we combine all the data together. Oh yeah, this is from Octopus. He made this code that resolves names. So some people have duplicate names in the data set. You know, you might have Septimus with a capital Z or Septimus with a lowercase z. So this code here finds all of those. This is called entity resolution. So Octopus provided this. It works really well. So after doing all this, there's still 10 names that are unresolved. And then he actually just manually, I think, labels the names that have no matching. And he matches them all, so then there's 0 remaining, so every name is resolved. And then we output the data set. Oh, we output the names dictionary, which maps, what that does, it maps all your duplicate names to your resolved name. So let's say we're going with all, I don't know, lowercase letters for everyone. I don't know if that's what we actually do, but I kind of forget. But let's say that's what we're doing. Then this would map Septimus with a capital Z to Septimus with a lowercase z. And it would map Septimus with a lowercase z to Septimus with a lowercase z. So it maps all your duplicate names into your one true ground truth name. So anyways, that works really well for removing all duplicates, essentially. Then we save the entire data set as praisedata.csv. So that's kind of the super data set. And then we can split into these, what we were looking at, receivers and quantifiers. There's essentially 2 types of praise. There's the normal praise that you think about, like where someone says, praise this person for doing this, and that's called receiving praise. There's also the quantifiers. These are like special adjustments made through the quantification process. So this is usually, they were using a process where some people are actually basically on salary. People are getting paid salary to be a part of the TEC and to help out and to build stuff. So they would actually get a reduced amount of impact hours. So if someone is on salary, then they might have their impact hours reduced by 50%. And this is just a manual adjustment that's done by the quantifiers each time. So there's essentially 2 types of praise. There's the normal receiving and then the quantifier adjustments. So we separate those out into 2 different data sets. What's this? Audit corrections. This is we were double checking. So basically I take all this data that we've now cleaned, and then there's also a sheet in here from the original data source that was meant to be like a final cleaned version of the data as well. So so Griff did a very manual sort of cleaning of all the data, removing duplicates and everything. And in here we did more of a data science approach to like sort of automated deduplication. And then we actually checked the results against each other. And oh yeah, so this is just loading the data. It's not actually checking if they match, but this is just loading the results page from the data set. It's a sheet called deduction audit results, and then it's saving it as its own independent CSV called audit results.csv. So that's just all data loading, extract, transform, and load. Very standard sort of data science process. Now EDA stands for exploratory data analysis. So let's just see what happens if we run this. It's going to load up the praise data, total hours, receivers, quantifiers. And it looks like it should be rendering a panel. But, yep, okay. So it's just a bunch of data sets. So we have the total hours given. Oh yeah, this is kind of fun. So we can see that Ivy praised a total of 8,000 impact hours. So she basically gave away 8,000 impact hours by praising people. Griff and this makes sense because Ivy, it's part of her job description to actually, she checks the praise recordings on Thursdays from the community calls where everyone's praising each other, and she actually writes those down and inputs them into the system. So that's why she ends up having 8,000. So that's a bit of an outlier. Griff 2,500, Livy 1,500, Jessica 1,400. And see what I think this is important because I think we should reward people for praising more. I think it's almost just as important to be praising other people as it is to be getting praise. So I think this should be weighted actually in the token distribution. So this is sort of a research topic for the rewards systems research that is going to be coming up. I mean, we've already kicked it off in the labs here, but the Token Engineering Academy is going to be doing a really big rewards research program. So this is all just getting a head start on that. Total hours received. So this is different from the final data set that you will have noticed before because these are unedited. So if you think about those quantifier modifications that are reducing praise by 50%, this is before any modifications are applied. So this is just total hours received, which is important because this shows the unfiltered amount of praise that people have received. So we have Sem with 1,200, Griff with 1,000, Livy 960, Zeptimus 850, Juan 820, Jessica 770, Tam 757, and YGG 647, Santi 621, Ivy 596. It's really important to see these because some people have a lot deducted. You can see Griff has 892 deducted, Sem 844, Livy 818, Juan 646, Tam had 642 deducted. And so this shows what's happening. We need to take a moment to reflect on our tools and think about if they're actually meeting the goals that we set out. And because it was pretty arbitrary, it was decided that roughly about 85 people who are on a full-time salary will have about 85% of their impact hours deducted. And that's pretty arbitrary. It was just pretty random actually. And then especially when you consider these are the core members of the community, people who are actually contributing the most. And yes, they are getting paid to be there. But they're also going to be the people with the most sort of understanding and cultural alignment with the community. And so if we're reducing 85% of their governance power, and all that governance power is going to other people who are not core members, it kind of skews the system. And so there was actually a vote to replace. So these people, this all happened from conflating governance with monetary compensation. Basically, the tokens, the impact hours, are a way of their monetary compensation for everyone who contributes to building the whole DAO. But they're also governance tokens. They're also how you vote. So since these people were essentially being paid cash, it was decided that they should be paid much less tokens. But then they end up having much less governance power, which is kind of a problem because they're the core of the community. So the solution to this that the community came up with is to produce tokens that are non-transferable. So they are basically have zero monetary value, but they still have the governance value, and distribute those tokens to these people. So you can actually decouple the monetary and governance aspects by having, they're essentially infinitely vested tokens that you can still use to vote. And then if you take total hours and you subtract the hours deducted, then you get this data set here, which is the sort of standard data set that we saw before. Okay, what else do we have? Twitter panel. Let's run this. Twitter augmentation. I think this is some work that Octopus did on... Yeah, this is analyzing tweets because there was a lot of praise going for people tweeting things. And then people are like, really? 10% of our money is going towards people making tweets? Like, isn't it more important to be building infrastructure or hosting working groups? So Octopus found that 10% of praise was going towards people tweeting. So this is a good way to sort of game the system if you want to just make a lot of tweets. And people were getting paid 0.55 impact hours per tweet on average. So if an impact hour is about, I don't know, $30 USD, then this means you could get paid like $17 or whatever just by making one tweet. And a total of almost 13,000 hours of impact were dedicated towards tweeting. And then this is looking at meetings. So attending, meeting, call. I think maybe we sum these, so we get just under 10%. Oh, about 10% of praise went towards people attending meetings as well. Cool. Oh, so I think Octopus made this. This is really cool. I haven't really looked at this much. But I think this is saying if we wanted to adjust the amount, so by default, it should be 0.55 impact hours per tweet. But we can see how the praise would be adjusted if we wanted to decrease the weight on tweets. So if we say actually tweets should only be 0.1 hour impact hour per tweet, then we can just see how things are adjusted. So impact hours from tweets. So let's see, Zeptimus has 7, Griff has 7, YGG has 3 if it's adjusted. So the default is more like 41, 39, 32, 31, 26. And we have a total. So this is kind of a neat dashboard. We can see how things change as we weight tweets differently. So this is the universal basic income intervention. So this is saying, what if we gave everyone a default this is cool. So this is okay. So this is the default distribution. So this is on the x-axis. This is just actually like index, or you could think of it as ranking. So on the very far left here, we have the person with the most impact hours earned. So I think that would be Zeptimus. And then on the number 2 is the person in second and third and fourth. And so 100 here is the person with the 100th most impact hours. And then on the y-axis, we have percentage of distribution. So we can see that and we have the table here for a clearer picture. So we can see that the person with the most impact hours has 686, and that's 5%. This is labeled kind of wrong because it says percent, but it says 0.05, but it's actually 5%. So this column should be times by 100. I wonder if I could fix that. It's percent of distribution. I'm not going to mess with it. But yeah, anyways. So the person with the most impact hours has 5% in this case. But if we apply a UBI, so let's say we give default 15 hours to every single person in the distribution, then we can just click this and see what that looks like. So everyone has now increased by 15 hours. And so you can see there's this sort of minimum instead of the plot sort of continuously decreasing, it hits this like minimum threshold where everyone who has participated in the hatch will be guaranteed, a certain percentage of the distribution. And so that you can see that reduces the person in first from 5.4% to 4.3%. And so it just gives a bit of a curving to the top of the power distribution. And we can turn that up. So we can say, what if we gave everyone not 15 hours, but like 100 hours? Then it raises that floor amount quite a bit. So we're giving a real more sort of UBI model towards everyone who has participated. And the person in first has gone from 5% of the total distribution down to 2%. So that's a constant UBI. Now I have this other thing I made, which is called a Gaussian UBI. So what this does is it's meant to reward the middle class. So I'm just going to turn off the constant UBI and turn on this Gaussian UBI. And what the Gaussian UBI is it's basically a distribution. So you can think of like a bell curve. And it's going to be centered around the like median sort of average middle class of this distribution. So it's probably around this this area here, which is like, let's say the 25th to 50th to 75th like ranking of people, so just under the sort of L of the hockey stick curve. We call this like the middle class, and it's going to have a weighted distribution that is a bell curve centered at that area. So we can see that as we increase, I call it the GUBI, so it's the Gaussian UBI, GUBI. So as we increase that, you can and then I can also increase the height. Oh yeah, so you can see where it's centered there. So if I put it to the maximum, okay, it's centered right at about 100. So the 100th ranking. And it just puts a bit more of a weight on that middle class. So you can see if we leave it at 0.02 and we center it, this number is how much it's the height of the peak. So the person who's right at that 100th ranking will get an extra like 20 impact hours. And so this is just a bit sort of nicer than the constant UBI, because maybe we don't, this person who only contributed like half an impact hour, who just showed up to a call once for 5 minutes, maybe we don't want to give them an extra 15 impact hours, So this Gaussian UBI will reward people who actually contributed significantly, but aren't like in the very top of the distribution. But I think it's best to use these two things together. And we have a metric here called the Gini coefficient. So we can see by default it's 0.67. And the Gini coefficient is a measurement of the distribution of power or the distribution of money in an economy. And actually the lower the number, the more distributed the economy is. So I think the UN, Octopus did a lot of research on this, or it's like the World Economic Forum or something. They say a well-distributed economy will have a Gini coefficient below, I think it was 0.4, something like that. So we can see that our default is 0.67, which means we have a very skewed distribution towards the top handful of people in our community. So it's kind of nice to try to get that Gini coefficient down. And if we turn on both this constant UBI and the Gaussian UBI, then we can get that Gini coefficient down below 0.4 and have a more equitable distribution. Now there's some controversy over this coefficient, saying, you know, a DAO is not an economy and we should be using different metrics. And some people say even in economics that this Gini coefficient is not a good measurement. So Octopus did some research on different metrics that we can use to measure sort of equitability and the distribution of wealth in our community, but it's just a baseline value. It's just a number that we can think about at least as we apply these different interventions. So those are the UBI models. I'm not sure what else is going on down here. I think there's, I take these default values and I apply them to the data set, and then I output a data set called UBI augmentation. Okay, so then we have wage deductions. Maybe I'll just take a moment here. And so we've looked at UBI models. We've looked at adjusting the tweets. We've taken a look at just the general data and how many impact hours people were deducted. Does anyone have any questions, or is everyone asleep?
I'm not asleep. I don't have any questions really. But that's wild about how much the tweets were getting.
Yeah, that's pretty crazy. It's good to just open up the data and look at it. Even if we don't change anything, it's nice to just be aware that that was, you know, half an impact hour per tweet on average. That's quite a bit.
So what is the goal of the research based on this?
So I'd say there's two phases. So this work was done a few months ago in around July. I think maybe May, June, and July. And the goal of the research at that time was to actually, because this is a real system that has since launched. It's called the hatch phase of the Token Engineering Commons. And it's a token distribution. So when we look at these numbers, these are very real. They represent the distribution of tokens. I think we have it, we're here, it's a percentage. So let's look at the default. So in this case, the person who has earned the most impact hours is going to get 5% of all the tokens that are created at this phase, which is called the hatch phase. And this is particularly the sort of the workers' compensation. It's called the cultural build because it's everyone who has contributed to the organization prior to the actual launch of the token. So this person's going to get 5% of those tokens based on the work that they've done. And those tokens are going to be used to vote. Like, it's kind of like one token, one vote. It's not quite that way because it's actually quadratic voting. So it's n tokens equals the square root of n votes, which is kind of cool. But we wanted to just take a moment to reflect and say, is the system that we've been creating, is this distribution of, this is a monetary distribution and it's also a governance distribution. Does this reflect the values of our community? Are we setting ourselves up for success? You know, because this is all very much an experiment. The whole praise system, this is the first time it's been used like this. So no one really knows sort of where the kinks might lie. So the goal of this research was to open up the whole praise data set, analyze it, analyze the distribution, and then suggest possible interventions, or I actually prefer the term augmentations, to the data set. So, for example, applying a UBI, that's an augmentation that might give a more sort of equitable distribution to the entire community. And then we had the chance to vote, and that's what we use Tokenlog for, to vote on different interventions. And so that was the goal at that time, to offer a window of time that we could augment the system before like the point of no return, like before the whole hatch, which has since launched. And the augmentation that we came to was a hybrid. The community was actually very much split in half. Half the people were voting for something called Praise-mageddon, which was Jeff Emmett saying, like, hold on, guys, like, this is way off. Like, this distribution is terrible. Look at that Gini coefficient. Like, we need to really go in and change this. And then there was another proposal from Griff, which was no abnormal intervention. He was basically saying, don't touch it. Like, the system's fine. We've all been working with it. We've all agreed to it. Like, don't change anything. He was actually suggesting one modification, which was the return of governance to the people who have had the deductions. So this is like the infinite vesting tokens. So those were the two proposals, and they very much split the community in half. And so finally, there was kind of a big call, a community call, and it had been written in the parameters of the Token Engineering Commons long ago, long before this whole controversial vote. Someone had written, I think it was Griff, had written, or Livy, had written about this case, like what happens when our community is split in half, and proposing this idea that we don't just fight to the death and, you know, whoever gets 51% of the votes takes it, as is done in typical politics, presidential elections, but rather we compromise. So if the community is split in half, then probably there's pros and cons on both sides. So we should actually come together and make a new proposal that addresses all the concerns of both sides. And so this is what was done. They actually just quantitatively like merged the two proposals. So Jeff was suggesting, you know, a whole bunch of interventions, UBI and all this. And so the midway point between, let's say his proposal was give everyone 15 hours of UBI, 15 impact hours of UBI. Well, the compromise between that and 0 impact UBI would be half, which would be 7.5. So basically all the interventions that Jeff was proposing, we just scaled them down by 50% and then applied them. So that was the goal of the research prior to the hatch. Now there's sort of a new phase of the research, which is not like, how did I put it? Like last chance or point of no return. So, but now the thing has already launched. The hatch has taken place, but this is more of a retrospective analysis of like, how did it work? You know, how did it go? What directions can we take this research? Like, what do we need to know? What should all organizations, decentralized organizations, know about this idea of UBI, the idea of praise, the idea of, you know, rewarding people for tweeting, the idea of rewarding people for being in meetings? Like, it's more of a very general research topic at this point, which is what the Token Engineering Academy is going to be kicking off. And so this was really a focus on the praise dataset, but now the Academy is going and reaching out to a whole bunch of different DAOs and saying, hey, do you have a rewards dataset? Can we have your rewards dataset? Because we want to generalize this research to not just the Token Engineering Commons, but across all DAOs, and say, what do they have in common? What do the distributions look like? What are the fundamental kind of like interventions or augmentations that we can be making to rewards? Which reward systems are the most effective and why? So two phases. One was to augment the system as it launches, and this phase 2 is more of like a general, more sort of academic style investigation or survey analysis into the idea of reward systems in DAOs. And that's going to be starting in November. So the Token Engineering Academy reward systems research group is going to be starting in November. So we're just getting a head start in the labs here, opening up these ideas and scratching the surface. Good question.
Thanks. I wasn't expecting such a storied history.
Yeah, there's a lot. Oh, there's definitely got to be a documentary about all this one day. It was quite dramatic. But I was loving, like, when the community was totally split, it was really interesting because usually the Token Engineering Commons is like all lovey-dovey, everyone's having so much fun and praising each other. But it was the first time where, like, it was really split in two. Like, half the people were on one side, half the people were on the other side, and there were some very heated debates going on, even, you know, people sort of becoming a little bit mean even, and it was just interesting to see that, how people can shift in different environments. So in this section, it's simply, we're basically taking these data sets we looked at earlier, which is like wage deductions, and putting them together and scaling them. It's a lot like this idea where we can scale back the weights on tweets, but it just hasn't been put into a slider. It must be a constant amount. Here it's 0.4. So we're taking the total hours deducted. We're scaling them by 40%. And then, yeah. And then we're just saving that data set. So we have the total hours deducted, and then we have those total hours deducted scaled down by multiplying by 0.4. And probably we're going to use that at a later point. So then if we take the total hours received and subtract this 40% wage, then we can get a reduced wage deduction. This was one of the proposals that was proposed by Tamara. Here we have a word count. I think this is just kind of cool. We take the entire praise data set, the reasons for dishing, and we do a word count to see what are the most common reasons, what are the most common words that come up in praise. So this might take a few moments to run. I'll just leave it. And then I think here we have basically a combination of all the previous notebooks. And I even went ahead and implemented this idea of gifting economy augmentation. So this is a bonus for people who, this is what I was mentioning before, where people who give the most praise should actually be rewarded for that. So I just set some threshold levels, or I cap it at 25 hours, and then it's scaled from there. So depending on how many hours someone has given of praise, they can get up to 25 hours bonus. So it looks like you need to have given about 100 hours. See, this Zargum only dished 2 hours of praise, so he didn't get the bonus. Mateo never dished any praise. Yeah. And then I guess this clean final probably really puts everything together and outputs a final data set. Looks a little bit messy. Deductions, audits. Okay, so then, yeah, these are just some verifications against the audits. Let's see how that word count is doing. Okay. So the two most common words are commons and stack. It's kind of funny. Helping, joining, community, us, thank, past, work, TEC, retweeting, mentioning, socials, spreading, message, week, grow, TE, token, engineering, call, pray emoji with a grass emoji, working, impact hour, community, comms, praise, sync, amazing, paid, working group, great, call, gets, be, making. So it kind of shows the gist of what people are praising for. A lot of like community and helping aspects, social, and it's funny how they kind of cluster. like retweeting, mentioning, socials, spreading, message, all have almost the exact same, so they probably show up a lot together. Same distribution. Token engineering, those two words have almost the same distribution. Yeah, so this is just a little toy example of how we actually have a very rich data set here with all this language. You could do some interesting natural language processing with neural networks, that kind of stuff. It's a very rich data set. And that's the essence of what's coming next with this rewards systems research group is, you know, what other kind of data science can we perform on this data set? And then also taking this data set but from other communities. And there's lots of DAOs out there and they all have different reward systems. So what do all the different distributions look like? And just doing general data science across reward systems is going to be really interesting. And so yeah, this repository, I've linked it in the agenda and also in the labs channel. So if anyone wants to, you can even just directly, if you open this up on GitHub and go into YGG and then outputs, you could download any of these data sets directly if you want to take a look at them. And this is like a sneak preview of what's going to be coming up a lot starting in November with the Token Engineering Academy's research reward system. So if you want to enroll in that, check out the Academy, jump in there. I'm not sure exactly where the enrollment is, but I'm sure you can find it if you poke around their server. Or message Angela. Yeah. So that's pretty much it for today. Anyone have any discussion points in the last 5 minutes?
I don't have any questions, but I got a lot more clarity on like the things that have gone on the last few months with the praise quant. I'd kind of heard about it, but I didn't really understand exactly what had happened. Thank you.
Thanks, Metaverde. Yeah, it was quite a blur while it was happening. It was some very fast-paced research, and if you take a look at the original, there is, if you go Commons build, I think there's a whole repository just for praise research, and it's crazy. There's like 50 notebooks in there. So it was a lot of research really fast. So there is this praise analysis repository, and there's all sorts of data in here. There's tons of research notebooks and everything. It was pretty crazy. It was me, Octopus, and Mohammed just hacking every day. But I've really consolidated down the essential stuff into the Impact Hours repository here, Impact Hour Intervention. So yeah, it's nice to be able to, and it was such a blur for me that opening it up today, this is the first time I've really opened it up since the majority of the research was done, I guess in July. So it was nice for me to see that it's good that it was left in a pretty clean state in this case. And it's nice to kind of review it. And yeah, there's some good stuff in here that can be definitely reused for future research.
Yeah, the whole figuring out compensation for participation is really, really hard.
Yeah, everyone's trying to solve it. So it's exciting times. All right, everyone. Thanks for joining again. And labs happen every Friday at this time. Feel free to pop in and check out the Token Engineering community server if you're interested in continuing the rewards research. And other than that, have a great weekend. It's Canadian Thanksgiving for anyone in the north here. Yeah.
Thank you.
All right, y'all. Have a good weekend. I'll see you next time.
Thanks, man. Bye.
Bye.
Thanks, Sean.
Bye.
Take care, guys.